All right, we're going to go ahead and continue with where we left off yesterday. This is the last section of new material. So we're going to cover CR 24 today and also 11.6. And that's going to be it for all the new material. Now we are having class tomorrow. Tomorrow is going to be a review for test 3. So test 3 is coming up on Monday. So we'll be doing, again, the review tomorrow for test number 3. And then for next week, Monday is test 3. So you have all day to do it, the 24-hour period as usual. Next week, Tuesday and Wednesday, both of those will be review days for the final exam. And the final exam is going to be on a week from tomorrow. So basically, it's next Thursday is when the final exam is going to be. Same thing, you have all day to take it as usual. And we'll do reviews for that one. All right, also as a reminder, you still have your bonus review assignment is currently open, and that's going to be open all the way up until the day of the final exam. So next week, Thursday, is when that's going to close. That's also the official end. Last day of class is going to be next Thursday. So that bonus review assignment is available for you to do, and you can earn up to 5 percentage points on the final exam. So the questions that are on there are very similar to the ones that are on the actual final. So it's a very good tool to use. Plus you can get some extra credit as well. Now you don't have to submit your work for the review assignment. So the review assignment, you don't have to show work. It's just for test 3 and the final exam. You will have to scan your written work as usual for as we do for all the exams. Okay, so let's continue here. Yesterday, in this section, we talked about the graphing method, and graphing method's okay, but then you need a grid for that. And then what happens if the coordinates are not whole numbers? If they're like 1/2 or a square root, something like that, you're not going to be able to graph that with any kind of accuracy. So that's why we are referring now to these two algebraic methods, a substitution method and elimination method. Okay, so we'll do for the substitution method, what that involves is you're going to solve for one of the variables and then plug it into the other equation. Typically for substitution, you want to look for, if there is a variable that's isolated by itself, that's generally the one you want to solve for, because then that allows you to solve for the variable without doing an extra division step and getting fractions. So what I'm going to do is I'm going to start with 3x minus y equals 11. And I want to solve this for y because I see that there is nothing in front of the y, and that's going to make that easier to solve for. So I'm going to add the y to the other side, y plus 11, and I'm going to subtract 11 to the other side. And so I get y equals 3x minus 11. So now I'm going to take this, I'm going to substitute it into the second equation, the one I haven't used yet. You don't want to put it back into the first equation because then everything's all just going to cancel out, and that's not going to allow you to solve for anything. But if you put it into the second equation here, we'll be able to get rid of one of our variables. So I got rid of the y, replacing it with 3x minus 11 equals negative 16. So that one step right there, now I just have x to solve for, and that's what I'm going to do now, solve for x. So I'm going to multiply all this by 15s, or by 5, so I get 15x minus 55. And then I just want to add the like terms, so I get 13x minus 55 equals negative 16. Add the 55 to both sides like that. And so by doing that, that's going to allow us to solve for the x. So in doing so, that's going to allow us to get our answer. We have, this is 39 there, x equals 3. Okay, so 39, divide both sides by 13, and we get our first answer. But this is not our final answer, because remember that these types of sets of equations, system of equations here, they require you to get a coordinate as your answer. We already found the x. So now what we'll do is we can just go back into the y. So I have y equals 3x minus 11, and then just put the 3 in there to get the y value, which is negative 2. So now what I would write as my answer would be 3, -2. So remember to always find x and the y. Your answer always has to be a coordinate. My open math will always remind you that if you don't put the parentheses around it, it'll let you know. You have to put the parentheses around it in order for it to be marked correct, because that's considered a point. If you don't have the parentheses around it, then you just have a list of 2 numbers is what it interprets that as. So that's why you need to put the parentheses on there, and it'll tell you about that with syntax and so forth when you do that. Okay, so that's that one. Let's do another one. Okay, now this one, we don't have a single y that's by itself. So if that's the case, then you just go for either equation. So I'm going to go for, in the notes, I went ahead and solved for this bottom one because it's actually a little bit easier when I solve. But so I could solve for x here, or I could solve for y. It doesn't matter. I'm going to show you an example of one where you have a fraction in it, and you can still solve for it the same way. Let's suppose that I went for this one instead. So I want to do this differently than I did in the notes, because I did the easy way in the notes, but I want to, but that's not always obvious to see which equation to use. Now, you're not wrong if you go ahead and use one of the other equations. That's why I want to show you this one instead. So I have -3x minus 9 right there. And by dividing this, that's going to get me -3/2 x minus 9/2. I could have as easily solved for the x as well, and I don't have to solve for y every time. It could either be x or y. It doesn't matter which one you want to solve for. But now that I have this, I'm still going to stick this into the second equation. So I have 2x minus 4 times -3/2 x minus 9/2 equals -6. So I need to multiply all this. So I'm multiplying both of these by -4. So it's a little trickier. You need to be careful with the fractions here. But if you do -4 times -3, it's 12 divided by 2 is 6. So we get a plus here because you have a minus and a minus. So plus 6x. If you take -4 times -9/2, you're going to get a positive 36 divided by 2. And that's going to give you a positive 18 there. Okay, so now we're going to add this together. We get 8x plus 18 equals -6. We're going to subtract the 18 to the other side, and we get -24. Divide both sides by x, and we get -3 for the x value. Okay. Now that we have that, you can put it, since we already solved for y earlier, we'll put it back into there. So y equals -3/2 x minus 9/2. So we have -3/2 times 0. I'm sorry, no, it's -3. Okay, so -3 in there, minus 9/2. Okay. So then when we multiply this, we're going to get positive 9/2 because that's 3 over 1 when you multiply that. That's why you don't multiply the top and bottom. It's just the top number gets multiplied by -3. That's actually what happened this other step here. I have -4 over 1 times -3/2. So that's the reason why when you multiply across the top, across the bottom, you just get 12/2 here, and then you get 36/2 when you multiply across there. So just want to make that clear. You can always put a 1 underneath the number you're multiplying. So with that, we get 9/2 minus 9/2, so you get 0. Okay, so your answer is -3, 0 is what you put. Now this is the same answer that we got in the notes, but this method, this way, is a little bit harder because you have to deal with the fractions. You'll still get the right answer, but you just have to be extra careful with the fractions. Whereas the way I did it in the notes, I took the bottom equation and solved for x instead, because I noticed that everything here is divisible by 2. So if I choose to solve for the x, the second equation, then when I solve for x, everything is divided by 2, and then I don't have any fractions. So that would be a little easier way of doing it, but I just wanted to show you, if you didn't recognize that, you're not going to be wrong by doing another method. You just have to be a little careful with the fractions and dealing with that. And so that actually leads me to my, we have another, like one more we're going to do with substitution with that. Now these have single x's, but in cases like this where you don't have single x's or single y's, that actually lends itself to the next method we'll talk about, which is the elimination method. So we'll talk about the elimination method a little bit later here, and that allows you to be able to have an easier way of solving for x's and y's if you don't have a single variable that's there. But this one will do. This one has a single one, so this doesn't matter what number, which one you solve for, either x or y. I'm actually going to start with the second equation, so you don't have to always start with the first equation. You can use the second equation. So I think it'll be the easiest to solve if I start with this one here. So I got that, and I'm going to add 3y to the other side. So I have 3y plus 34. Now I'll just put this into, since I used I worked with the second equation, now I want to put this into the first equation. So 5y minus 3y plus 34 equals negative 58. Thing you got to be careful about on this problem is there's a minus sign and you're subtracting the entire x. So you do need parentheses around the entire thing you're putting in, because the minus sign gets distributed to both things inside. So you'll end up with 5y minus 3y minus 34 equals negative 58. These, you get 2y minus 34 will equal negative 58. And so we're just going to add the 34 to both sides there. And we're going to get negative 22 there. If you divide by 2, you get 11 for the y right there. And that's going to be, again, that's not just your only answer. Okay, remember that these kind of problems, you do need the x and the y coordinate on that. So, so you know what? This is a sorry about that. This is a 54, not. This is a, yeah. Let me erase that here. This should be a 24, not a 22. Okay, so this is 24 there, which means that this is going to be a 12 instead. So that's a 12 there. Okay, so 12. Okay, so now we're going negative 12. And we're going to put this now into the x. So we have x equals 3 times negative 12 plus 34. We have negative 36 plus 34. So you're going to get negative 2. So negative 2 and negative 12 is what you're going to get for this one. Okay, so that would be your answer on that. Okay, so moving on here, we're going to go to the elimination method. So elimination method is a good method to use if you don't have a single x or a single y term. That's when you want to use the elimination method. So in this case, we don't have any x's or y's that are by themselves. So because of that, we can use the elimination method. Now, what the elimination method involves is multiplying one equation or sometimes both equations by something, so that when you add the equations together, you'll get one of the variables to cancel out. Now, you can choose to eliminate either the x's or the y's, but depending on which one you choose, you may have to multiply one equation or two equations. So you want to look for whatever one is easiest. For example, if I want to eliminate the x's, the smallest number that both 2 and 5 will divide into evenly is going to be a 10. So I could make one of these a negative 10 and one of them a positive 10. So when I add them together, the x's will cancel. So that's one way I can do that. Now, if I take a look at the y's, I see that the largest number that both 3 and 6 divide into evenly is actually going to be 6. 6 divides into itself and 3 divides into 6. So because of that, I only would need to multiply the first equation in this case. Of course, I would need to just multiply by 2 to make that a 6. But then when I add it to the bottom one, that would add it together and then cancel out the y's. So that's the method that I'm going to use here. I'm actually going to multiply the first equation through by a 2. So I have 2x plus 3y equals -4, like that. And on the bottom I have, I'm not going to multiply the bottom one by anything. I don't have to multiply because I already see here that if I multiply this by 2, I'll get 6 and -6 will cancel out. So in that case, I only have to multiply one equation by something. But again, if you choose the x's, then I'd have to multiply both equations by something. So you're just looking for whatever way is the easiest. So I have 4x plus 6y equals -4. And then I have this is the same. I didn't do anything there. And what we're doing is we're adding. So you're always going to be, you're usually going to be adding equations together here. So adding this, you get 9x. That's going to cancel out and get rid of that variable altogether. Okay, and so in doing that, by canceling that part out, then you're going to get a 45. Oh, you know, I forgot one thing that was very important. This is actually, I actually made the same mistake that I see most people making on these problems. You have to remember to distribute all the way through both sides of the equation. So I only multiplied the first 2 by 2, but I missed the last one here. So it's very important, whenever, if you're multiplying the equation, make sure you multiply both sides by the 2. Okay, so we're multiplying the whole thing by 2, so that should be -8, not -4. Now that it's correct, we can add that together and we'll get -45. Dividing by that, we get a -5 for the answer. So x is -5. Now this time we don't have an equation that's solved for y to plug this into. So we have to use either one of these two equations. So we can just take -5 and plug it either into the first one or the second one. In this case, it doesn't matter. So I'm going to use this first equation. And since I know x is -5, I can plug that in there. And now I can solve for the y. So -10 plus 3y equals -4. Add 10 to both sides. So if I add 10, I'll get a 6. Divide both sides by 3, and I get y equals 2. So the answer would be -5, 2 for this one. All right, so that is now complete. So again, the key on here, you're going to use the elimination method and you're multiplying both equations by something. That's the key step right there. Make sure you remember to multiply the right-hand side of that. All right, so next one, another one we're using the elimination method. So this, again, this one, actually there's no advantage for solving for either x or y. This is actually a case where no matter what, I'm going to have to multiply both equations by something. This time, let's eliminate the x's since we eliminated the y's last time. Now, if you want to eliminate the x's, you want to look for the smallest number that both 3 and 15 divide into evenly. And that's going to be 15. 15 divided by 3 works, and 15 divided by 5 works, so that's the smallest one. You want to make one of them positive and one of them negative, so you can either multiply the top row by negative or the bottom row by negative. It doesn't matter. I'll do the top one. So I'm going to do -5, and I'm going to multiply the whole equation by -5. But the bottom one, I'm going to multiply by a 3. Okay, so a +3 there. So I get this one, multiplying again the entire equation, remembering to multiply both sides when we do that. -15x minus 20y equals +55. 15x plus 9y equals -33. And we need to add all that together. X's will cancel as we wanted. This we're going to get -11y. And then we'll get 22 here on this side. Divide both sides by -11. And we get our first answer, -2. And then we just put this back either into the first equation or second equation, doesn't matter. I'll use the first one. And I'm going to put the -2 in for the y, since that's what we already solved for. And then just solve for x. So this is going to be 3x minus 8 equals negative 11. We're going to add 8 to both sides. And if we divide both sides by 3, we get negative 1. Now, one thing you want to be careful about when you're writing your answer, it's easy to accidentally just write in negative 2 comma negative 1 here, but remember the x value has to go first. So that's one thing you want to also remember. That's a mistake to avoid. Making sure you put in the correct order x and y. All right, one more. Let's do another one, a couple more here. All right, this one, it says solve using, so again, we're using elimination method here. And the next one, it'll give us a choice of which method to use. All right, so this here, if we take a look at that, we want to eliminate either the x's or the y's. If you notice the x's here, there's a 6 and a 3, which means I would only have to multiply the bottom row by a negative 2 in order to make the x's cancel out. But then if I try and eliminate the y's, then I have to multiply both equations by something. So I think it'll be easier to eliminate the x's here. The top row already has, top equation here, that already has the 6 in there, so I don't even need to do anything with that. But the bottom one, I'm going to multiply by a negative 2. I need to put a negative there because, again, the idea is you're adding the equations together. So you want one positive, one negative, so that those variables cancel out. So the top row is going to stay the same. The bottom one, and 6x plus 6y equals negative 8. And I'm going to add all that together. Okay. Now in the notes, by the way, the notes, I did do this one by substitution. Well, actually, in the notes, you can do either one, but because it says specifically elimination, that's why I'm doing that. This one here specifically, but it says any method, then you can use any method. In fact, the test question is going to have any method as well. So when you do that one on the test, it'll say any method, so you can use either one. The homework questions are a little bit more specific. They actually say elimination, substitution specifically, but on a test, it'll be more like this bottom one. You can use any method you want. All right, so I have that one there right here. And so now we get 11 on this side. So I get y equals 1 when I solve for that, divide both sides by 11. Now I'll put it into either top or bottom. We can use the bottom equation this time just because the numbers look smaller. Okay, that's the only reason why I'm choosing that one. But again, it doesn't make a difference which equation that you actually use. So I'll just use this one, just like that. 3x minus 3 equals 4. We add the 3 to both sides and we get a 7. So we do get a fraction here on that one, which is okay. Sometimes we do get fractions as a result for one of the components, but that's fine with that. So that would be your answer on that one. Okay. Next one, we're going to, we can solve it by using any method. Okay, so with this, solving any method, we can either use substitution or elimination. In the notes on this problem, I did use substitution, so I'm going to show you elimination instead, just to show you could do either one. So I have a 3 and a 6 here, and a 1 and a 2 there, so I can actually eliminate either one. It doesn't matter. So what I'll do is I'll go ahead and eliminate the x's. So if we're going to eliminate the x's, you get 3x minus y equals 4. And then you have the bottom equation we don't have to do anything with. Okay, so I'm just going to do that. Negative 6x plus 2y, plus there, equals negative 8. And I have 6x minus 2y equals 7. I don't need to do anything with that one. Add it together, and I get a 0 equals negative 1. Now, 0 equals negative 1 is not a true statement. So if you get this, it doesn't mean that you did the problem wrong. It just means that there's no solution on this. So if you get something like this, this means no solution. In the notes, when I did it by substitution, I got another false statement. I got 8 equals 7, which is also false. That would tell you it's no solution. So whether you use substitution, elimination, if you get something that is a false statement, it's no solution. Let's suppose instead that we got like 1 equals 1 or 0 equals 0, 0 equals 0, something like that. Then this would be an example of infinite solutions. Okay, so that's the two differences that you're going to come to. You're going to get a false statement. If it's false, you get no solution. If you get a true statement, then it's infinite solutions. Okay, so in that case, that's what's going to happen. So if you solve for either substitution, elimination, you get a false statement, no solution. If you get a true statement, infinite solutions. This could be 1 equals 1, 0 equals 0, anything like that is considered infinite solutions. All right, now we have another one here that has to do with this is solving, you can use any method here. So there's some fractions that are involved here. So it's probably going to make sense to clear the fractions out first. So what I would do is just multiply each equation by what's in the denominator. That'll allow you to clear out the fraction. So the first equation, I'm going to multiply by a 3. And I'm going to multiply everything. Now this is not elimination method I'm using here. This is actually just to clear the fractions out. The bottom one, there's a 2. So 2 in the denominator. So I will multiply this. So this step, all I'm doing here is getting rid of the fractions. And so then I can use, once I get done with that, then I can use substitution or elimination. Multiplying that by 3, I get 2x minus 3y equals 20. And I get 4x minus 5y equals 34. So in that one step, I've eliminated all of the fractions. Now at this stage, I can use either substitution or elimination on that. And so in the notes, I did this one by elimination, but let's do this one by, we can do this by substitution as well. Now, if we do it by substitution, we are going to involve some fractions as a result, but let's still do that anyway. Let's start with 2x minus 3y equals 20. Just want to show you a different method than what I did in the notes, so you have a little different idea how it works. Let's solve for x here. So I'm going to get 3y plus 20, divide everything by 2, and I get x is equal to 3/2 y plus 10. If I'm doing this by substitution, that means I would now put this into, now you don't have to put it into the original equation with fractions, because then you get fractions and more fractions. It's better to put it into one of the bottom ones. So I'm actually going to stick it into the first equation here again. So I'm sorry, into the second equation, because since I just solved for the first equation, I need to put it into the second equation. So second equation, I'll put this into, again, you don't need to use the original 2x minus 5/2 y. You don't want to use that one. You want to use this one here, 4x minus 5y equals 34. So 4 times 3/2, 3/2 y plus 10 minus 5y equals 34. We're multiplying this by 4, so we're going to do that to each thing. Remember, this is a 4/1. So you get 12/2, which is 6y. 4 times 10 is 40. Minus 5y equals 34. 6y minus 5y is just y. So y plus 40 equals 34 there. And then if you subtract the 40, you get -6. So -6 is going to be the answer for y. So now we just have to solve for x. We can do that by just going back up to here. We solved for x earlier. So we're going to do x equals 3/2 y plus 10. We'll put the -6 in there. Then we'll solve for that. This is 6/1, so it's -18/2, so -9 plus 10. And so then we end up with x equals 1. So the answer we get is 1, -6. So again, you don't have to do it this way. I just wanted to show you the alternative, showing you another method with substitution, but it does say use any method to solve. So you could use substitution or elimination. So if you want, you can take a look at my notes to see the way you would do this with elimination. Elimination, it'd probably be easiest to multiply the top row by -2 and add the equations together. But I did it instead by substitution, which also worked as well. We just had the one fraction to deal with, so that wasn't too bad for this one to plug in and use with substitution. So again, on a test, it's going to have either or, substitution or elimination, and you can just choose whatever one you want for that. Okay, so we're done now with the CR 24 section. And so now we're going to go on to, this is the last section of new material that we'll do for this course, and it's going to be 11.6. Okay, so we've done systems of linear equations. So now we're going to take a look at systems of nonlinear equations, and that's going to be in the next section here. So we're going to take a look at section 11.6. All right, so 11.6. Okay, so 11.6 for that. All the instructions are just going to say solve the system or solve by any method, something like that. So I can solve this by using any method here. So I want to pick either, I'm still going to use substitution or elimination. So the same techniques we learned in the last section. You probably don't want to use graphing, because then you're going to have to graph things that we haven't, like there's parabolas and hyperbolas and different things that we haven't talked about graphing yet, that much detail. And so we're not going to worry about the graphing method at all. In this section, it's either going to be substitution or elimination is what we'll use here. Now, in this case, because a y is already solved for us, it makes the most sense to go ahead and use the substitution method, since we already know what y is equal to. So that's what I'm going to do. I don't even have to solve for y. Y is already solved here. So I just need to plug this in for y. So I'm going to put it into the second equation. Okay, so instead of the y, I replace it with x minus 5. So now I've eliminated the y, and I have this x's left over that I can solve for. So now I just have to solve this, and so I have a quadratic equation, which means we're going to be, eventually we'll go back to factoring again. We'll be doing in this section. Now for this, be careful. This is the most common mistake I see students making. X minus 5 quantity squared is not equal to x squared minus 25. You can't distribute the square to both of those inside. It doesn't work that way. It only works with multiplication or division, does not work with addition or subtraction. Remember that x minus 5 squared really means this is what it's equal to, x plus 5 times x plus 5. So what you're actually doing here is a foiling step on that. So we're multiplying first, outer, inner, last. So we have x squared, and I'm going to put this in parentheses because we're subtracting the entire thing. So I want to make sure that everything I'm subtracting is inside these parentheses. All right, so x squared, so we have plus 5 and 5 is plus 10x, then plus 25, and it equals 5 over here. So notice I'm subtracting the entire thing, which means that the minus sign gets distributed here. So I'm subtracting all that all the way through. Now what happens there is now the x squares are going to cancel out, which is good. So those drop out, and I get negative 10x minus 25 equals 5. Add the 25 to both sides, and I get 30. Divide it, and I get negative 3. But just like the linear equations, I do need to find the x and the y on this. So I'm going to now put this. You can put this into either equation, but of course it would make the most sense to use the first one because the y is already solved for us. So y equals -3 minus 5. And I get y, so I get that. I'm sorry, I put that in the wrong. Yeah, let's put that right there. That's correct. So I went through all this. I solved for the x, and that's the answer. So I get -8 for the answer when I do that. Okay, so I did. So again, x squared minus. This is a minus here. I just realized that's not the right answer. My apologies. Okay, so this is not correct. Made a mistake right here, because this somehow I don't know why I put +5 there. It's -5 for each of these. Yeah, so x minus 5 squared is x minus 5, x minus 5. So that's a minus sign right here, and that means that would be a plus. We go there because you're distributing the minus sign. So that means that's a plus, and you get a +3 as your answer. So you have 3 minus 5 right there. 3 minus 5 means you get -2 for the answer. So 3, -2 is the answer you should get. So yeah, I'm not sure why I put plus there. X minus 5 quantity squared is -5 and -5 there. Okay, so we have that, and that's going to be 3, -2 is the first answer. Now, the second thing you're going to do, one thing you might be wondering is, well, what if I use the second equation instead? When did I get plus or minus if I were to plug that in there? Okay, so let's find out. Let's put that in there. So for this, that's the answer, 3, -2. But let's suppose we took our answer of 3 and put it into the second equation. So I'm going to show you that you don't have to do both equations, just one or the other. So I'm just showing you what happens if you were to choose the second equation. You get 9 minus y squared equals 5. Subtract the 9 from both sides. You get -y squared. -y squared equals -4. And so then if you were to divide by a negative, you get y squared equals 4. And then if you take the square root of that, of both sides, you get y equals plus or minus 2. So then you might think, well, then wouldn't I have 3, 2, and 3, -2? See, if you get two answers, you have to check your answer to make sure it works with both the equations. So if I have x equals, so this right here, I got 2 and -2. Well, if I take 2 and put 2 back into here, I'll get, if I put a 2 in there for the y, that means I need to get 3 for the answer for x. So if I put 3 in here, I should get -2 for y, and I don't. So for putting a 2 in here does not make a true statement. If I put 3 in here, 3 minus 5 is not equal to 2. So although it may work for the bottom equation, it doesn't work for the top equation. So in that case, I would eliminate my answer. The easiest way to avoid this confusion is just go for the easiest equation. If you have one where there's just a y that's already solved for by itself, then that's the one you want to use. You can use it with confidence that it will give you the correct answer, and so it eliminates automatically the bad answers. So that's why putting it back into the first equation is the best case here. If you have something like this where it's a more simpler equation where you don't have a square, and we'll look at a couple other examples we'll see in this section that do the same thing. But if you've got just an easier equation with no squares in it, then that's the one you want to go ahead and use, and just know that you will still get the correct answer if you use that. So again, you can use the second equation, but then you want to still make sure both your answers will work in the original equation, especially if you have one that has a square and one that does not. That's specifically one where you want to check both your answers. In case you're wondering what the graph looks like, I did provide a graph for you here, so you can see that it does in fact only have one solution. This would be the second equation, the one with the squares in it. Now, we're not expected to know how to graph something like this. This graph you'll take a look at when you go to trig. So for those of you taking 127, at the end of that course, you will go ahead and cover that. We cover that in my class. We cover that towards the end there. Now, the other equation is just a line, x minus 5. So we see that right here in red. we see that they cross right here at 3, -2, and that would be the point of intersection. So there is only one answer that it has in this is 1 point only, point of intersection. So that's why I wanted to explain all that for this particular one and show a graph. But you're not expected to know how to graph that. I think they have maybe some graphs and some circles and lines that you have. There are a couple on here that will ask you to do a graph for. Just going to check that to make sure. So I'm giving you the correct information here. I believe there is a couple where you do a multiple choice on that. Actually, there is one of them on here that you do have to graph, and it has to do with a parabola and a line. So that's some things that we've already talked about before in class. So if there's time at the end, I'm going to come back and I'll show you one of these from the homework so you can see how to do it. So again, there's for that, there's going to be just some circles, lines, and a parabola on that. One of them is a multiple choice, and one of them you're going to use the graphing tool. So I'll show you the one with the graphing tool, since that's a little bit different than what we showed in class as far as the graphing method is concerned. In fact, we'll actually go ahead and do that one now at this point. So let's take a look at this. I'm going to do so I'm going to pull up a blank page for you first, and let's take a look at a graphing one. So this is an additional example I'll show you here that wasn't originally in my notes, but it's one that's like the one in the homework for it. So I'm going to show you the first two equations. We have this and we have this, and it's going to ask us to graph these and find the point of intersection. So let's do the graphs of these first by hand, and then we'll use the graphing tool to answer it. The first one we have is 2x minus 2. So that means that that line is going to cross at -2, and then the slope here is 2/1. So basically this says solve the system by graphing. So we'll put the instructions here so that way you know what kind of problem we're doing here. Solve the system by graphing. -2, we're going to go up 2/1. So we have we can just keep doing that again, however many times that you want to do on that. That's what you would do. So we'll just do three points is enough. So we'll just draw this first line right here. All right, now this next one, x squared minus 2, that actually goes back to our transformation section that we did a long time ago. So if you have an x squared graph, normally it goes through these points right here. So I'm just drawing the just a sketch for the x squared graph. That's going to be right here. So this is y equals x squared. So we see that it goes through these key points. And what we're doing is we're moving this down 2 units, which means that the graph is actually going to cross right here at the axis. It does go through that point. So if we're moving it down, that means this point also moves down 2 units. So that means I have a point here, I have a point here, and these also move down 2 units. So that's going to move down 2 units to 2, 2, and then just move down to here. So I get my graph is going to look like this. Okay, so that's what it looks like when I draw that. So the x squared graph shifted down 2 units. So with that, let's go back now to we're going to go back to the actual problem in my open math. So let's do this one. Okay, so now that we have this complete, okay, I need to use the graphing tool. Let's use the top first equation. You need to use the Parabola Tool. And when you graph this, you have to start with the vertex. So I do want to start with plotting the -2. And then I also see that it goes through this point right here, or I could have clicked on this point. It doesn't matter. That locks in our answer for that one. Now, next thing I want to do is the line. And the line went through here and went through there as well. And so that's what your graph would look like. We're going to read off the graph. The points intersect. And so because there's two points of intersection here, so you have to separate those with a minus sign. So I'm going to do 0, -2. And then I have also 2, 2 is where it intersects. So it intersects there. And so that would be the two places, 0, -2 and 2, 2. And so then everything is correct. So that's where it intersects. Okay, so there is one question like that. You are going to do the graphing system. So solve it by graphing. So it is similar to the last section, but since I didn't have a problem like that in my notes, I did want to go ahead and do this one for you as an example, so you can see how this works. So with that, let's go back now to the notes again. Okay, so again, that's our final answer. You just read the answer off the graph on that one. Okay. So let's go back to where we were before. So I want to just take a little detour there and show you that graphing question on it, and everything else is more similar to what we're going to be doing here algebraically on that. So primarily for the rest of these, we're just going to use substitution or elimination, whatever one we feel is easiest. For something like this one, it's going to be easier to use substitution because I have a single x term that I can find here. So I'm going to solve for the single x. Now, of course, I could go in the first equation and solve for either x or y, but then that's going to involve dividing something there, excuse me. So instead, what I'm going to solve, I'm just going to start with this one and solve for x. So if I do that, I'll subtract x to the other side and I get -2y. Now what I'll do is I'm going to take and plug this into since I just work with the bottom equation, I'll plug this into the first equation. So I have xy equals -2. I'm going to take out instead of the x, I'm going to put in -2y instead. So I have -2y goes in there for the x. And then I still have multiplied times y equals -2. So I get -2y squared equals -2. And so then I can divide both sides by -2 to get y squared equals 1. But then I want to take the square root of both sides. So when you do that, you get plus or minus 1. All right, now this, we need to find the corresponding x values that go along with this one. So I'm going to use this equation, x equals -2y, and I'm going to do that with y equals 1 and with y equals -1. So if y equals 1, I have x equals -2 times 1, so x is equal to -2. And if I put -1 in there, I get x equals -2 times -1, so x is equal to 2. So when I write my answers, I'm going to write both of these as coordinates. So I need to put these into the coordinate form. And so when we do that, then we're going to get these 2 points down here. So this one is going to be -2, 1, and this is going to be 2, -1. So that would be your two answers that you would type in there, -2, 1 and 2, -1. We can check both of these to make sure they both work here. -2 times 1 will give you -2, so it does work for the first equation. -2 plus 2 times 1, you get -2 plus 2, that does give you 0. So yes, the first point does work. Second one will check also. You still have 2 times -1, which is -2, that works. A +2 here, and if you put a -1 in there for y, that gives you a 0. So yes, both of these are going to be your answer Okay, so far we've done an example of, we did the graphing one, we did substitution ones. Now let's take a look at one where you got to use elimination. Okay, so this one works for elimination because I have x squares and y squares, and so I can eliminate an x square or a y square here. So for this, I have a choice to either eliminate the x's or the y's. If I eliminate the x's, that means I need to multiply a row by -2 all the way through. But since I already have a negative there for the y, if I want to eliminate the y squared, I would just have to multiply by 3. So I think that's the way what we're going to do that. I'm going to take the first equation and multiply it by 3. In the bottom equation, I'm not going to multiply by anything, because if I multiply the first one by 3, I'll get -3 and +3 adding together will cancel that out. So that's why we'll just, I'm choosing to eliminate the y squares here. Multiply this through 3x squared minus 3y squared. 3 times 0 is 0, so that's there. The bottom equation is there as is. I'm adding this together. That's going to eliminate the y squares and the x squared. So I get 5x squared is going to equal 5. Divide both sides by 5, and I get x squared equals 1. And so x is equal to plus or minus 1 when I take the square root. Don't forget about the plus and minus. So you get 2 answers there. Next, you're going to put this back into either the first equation or second equation, doesn't matter. I'll use the first equation. I'm going to use x squared minus y squared equals 0. And I want to do x is equal to 1. And I want to do x is equal to -1 and plug it into here to get the answer for the y. When x is 1, I have 1 squared minus y squared equals 0. I subtract, I can either add the y squared or subtract 1, doesn't matter. I'll add the y squared to the other side, make it positive, and then I just take the square root of both sides and I get plus or minus 1 again for y there. Let's do the same thing with -1. I have -1 I'll put into the first equation. But what happens here is I'm actually going to get the same result from that. So I get the same, I'm actually just going to end up getting the same answers when I do that. But I still have to write them out in coordinate form. Now the way that you would do that is when I put x is equal to 1, I got both +1 and -1. So as a point, you would write 1, 1, 1, -1. When x is 1, I get both 1 and -1, so that takes care of that one. Then I'll take care of the second one. When x is -1, I get both 1 and -1. So I actually get four points of intersection on this one. So 4 places where it crosses. The reason why it is, by the way, is I'm just going to show you a real rough, super rough sketch. Essentially what you have here is you have a hyperbola and an ellipse. So both of these are graphs that you're not expected to know how to draw, but basically you would just get these 4 points of intersection if you were to look at the graph. That's why it has 4 places. You have the second equation is the ellipse, and the first one with the minus sign, that's the hyperbola. And again, these are both graphs that you're not expected to know how to graph now. You will learn that for those of you taking 127, that's where you'll learn how to do that. Okay, so again, 4 points of intersection we get for this one. This one, we do have a choice to either do that by substitution or elimination. Now, if you do substitution, you can only eliminate the x squares because notice there's not a typo here. That y is just y to the first power. Okay, so in this case, we can only use elimination to eliminate the x squares. But we could also eliminate the use substitution if we wanted to as well. Now, if you use substitution, you'll be getting into squaring a square, so you might get a fourth power out of that. But I'm going to go ahead and do it that way to show you what would happen if you try doing it. I did a different way in the notes, so if you want to go back and look at my notes or the video I have that's linked to this problem with the homework, I did do it a different way. I did it like the notes where I did it by elimination. So instead, let me show you substitution. Now, if you are going to do substitution, the only obvious choice would be the second equation solving for y. So I just want to show you what happens if you choose to do this by substitution, because for a lot of you, that might be the obvious thing to do because there is a single y there. And since I told you before in the last section, if you see a y by itself, then that's usually an indication that you would use any variable by itself, I should say. And that might be an indication that you might want to use substitution. So let's do that in this case. So I'm going to swap places with the negative y and negative 1. So I just move those to opposite sides there. Becomes positive. So now I have 2x squared plus 1 equals 1. Well, now I'm going to put this into the top equation since I haven't used that yet. I have x squared plus y squared equals 10. That's the equation I'm starting with here. But in this case, for that, now I'm going to move on to the next step, which would be to plug in all this for a y. So as I mentioned before, you have a situation where you have a square and a square situation happening if you were to do it this way. That's why sometimes the elimination might be a little bit easier in this case, but we'll go ahead and move on anyway with that. Remember what this means. If you have 2x squared plus 1 and you're squaring it, that means that you're doing two of these together. Okay, so you have to do a FOIL on this. Again, don't just square the first one and the second one. Okay, so you multiply this, we get x squared plus 4. Now that's going to be x to the fourth power. Okay, and I have a square and a square, so that's going to be plus 2x squared plus 1 equals 10. So I just expanded all this out. The next thing I want to do is add like terms. 4x to the fourth plus 2x cubed plus 3x cubed. 3 there, because I have a 1x squared and a 2x squared, so 3x squared. And that equals, I still have it equal to 10. Okay. Now it is quadratic in style, so what I would do here is I need to subtract the 10. So 4x to the fourth plus 3x squared. If I have 1 minus 10, that's a minus 9. And I have that right there. Okay, so at this point, we want to do a factoring step on this one. So with this here, again, this is different than the way we did it in the notes, but we'll go ahead and show this. Okay, so if you factor it for something like this, so again, just go ahead and make double check in the work that we did so far, just to review. I took this equation here, I added the y to both sides and added the 1 to both sides and got 2x squared plus 1. So then I'm starting with the second equation, or I'm sorry, the first equation that I have here, replacing the y with 2x squared plus 1. So I put that in there and I expanded it out. By doing that, oh yeah, I see what the mistake was here. This part right here is not correct. This should have been a 4 right here. Okay, so that's a 4 because I have a 2x squared and a 2x squared gives you a 4. So that's a 4 there, which means that this should be a 5. Okay, so that means that this over here is also going to be a 5. Okay, so now I have that. That makes more sense now. We need to factor this now. Wasn't working out before, that's why I wanted to double check the work and see. Because usually these kind of problems are ones where it's going to be able to factor. It's highly unlikely that you'll get square roots and stuff. There might be one question in the homework where you get a square root as your answer, but most of them are all going to be whole numbers. So these should be problems that you can factor. So if it doesn't factor, then you want to go back and check your work kind of like I did there. And that way it'll tell you whether you're on the right track or not. We're looking for two numbers that multiply to make 9 and add to be, I'm sorry, 4 times -9. So we're doing this by we can do this by two different methods. We can do trial and error, or we can do a grouping method. I'm going to do the trial and error method. Now, the thing to remember here is if you are doing it by the trial and error method, remember that you have a fourth power there. So if it's because it is a fourth power, you would have to put a 2 squared there instead. Okay, so in that case, what I have here is I've got for this, I'm going to try 2 and 2 first and see if that works. Okay, for 1 and 9, I have a 3 and a 3, so I'll try that. Now, if I multiply this, I get a 6. And a 6, that does not equal the middle term, so I know that 3 and 3 are no good. Let's try 1 and 9. Okay, I get 18 and a 1, that's not going to give me a 5 either. So that tells me that 2 and 2 is not the right combination. So instead, what I would do is I would try, if that doesn't work, then I would try a 4x squared and an x squared. That way, when I multiply that, I get a fourth power. Let's try this. Let's try this now with 3 and 3. 12 and a 3, that doesn't give me a combination of a 5. So 3 and 3 doesn't work. Let's try 1 and 9. 36 and 1 doesn't work either. So finally, we're going to switch all this, and this is finally going to be the right combination that's going to work for us. 4x squared plus 4 and 9. So I want to get a positive 5 out of this. So I'm going to do a plus 9 and a minus 1. I'm going to do there instead. Okay, so by doing that, that's going to give me 4x to the fourth power. I have a minus 4x squared and a plus 9x squared. That gives you a 5, and then plus 9 and minus 1 gives you that. So that's finally factored correctly. We're going to set both of these equal to 0 now. If I do this one, I get 4x squared equals -9. But then if I divide both sides by 4, I get x squared equals a negative number. And I know that I'm not going to get a real number answer out of this. These are questions you don't have to worry about trying to solve for I. It's just going to be the real number answers only. So if you have a square equal negative number, that's not going to work in this case. So that first one is no good. I don't need to worry about that. So the second one, if I add the 1 to the other side and square root, I'm going to get x is 1 and -1 as a result. Now, I'm not done yet because I still have to find the y values, but I can do that up here. Originally, I had 2x squared plus 1 equals y, so I'm going to put that back in and solve for that. All right, so let's put that into here. So I'll do that down below. 2x squared minus y equals -1. And let's move that some more space here. Let's do that down here. So I have y equals 2x squared. We set plus 1 there. If x equals 1, then we have y equals 2 times 1 squared plus 1, so I get y equals 3. And then if I have x equals -1, I have 2 times -1 squared plus 1, and I also will get a 3. Which means that my two points of intersection here are going to be 1, 3, 1, 3, and -1, 3. Now that's the same answer as we got in the notes, but I would say that probably the way we did it in the notes is going to be a little bit easier in this case. If you don't like dealing with higher powers, then you can avoid all that by just going back and using the method we showed in class where we're eliminating. The way I showed it in the notes, I should say, is you can multiply the first row by -2 and add to the second one. That's going to eliminate your x squares. So you can follow what I did in the notes and the video that goes along with this problem to see that method. But I just wanted to show you an alternative way of doing it by plugging something in But then if you're doing that, you do have to deal with the higher powers and you have to deal with a little bit more factoring. But both ways have their pluses and minuses, I suppose. But either way, you're going to get the same answer, 1, 3 and negative 1, 3 you'll get for those. So it's kind of your choice which method you want to use with that. Main thing is you've got to be careful when you're multiplying with the square in here, because you have the fourth power, and also be careful with your middle term as well. All right, let's do next one we have, and this is so this one here is another case where I see a complicated problem and I have an easier one that's here. So in this case, I am going to use substitution, and when I plug my numbers back in, I'm actually just going to use the first equation, not the second one. So let's start with the that's 3 squared. What I'm going to do is, since the first equation is already solved for y, I'm going to substitute this into the second equation. So I'm going to get negative square root x squared equals 5. I'm going to expand out the first one. So I get x squared minus 6x plus 9. So again, it's x minus 3 and x minus 3. The square is going to get rid of the negative and the square root. So I just get plus x right there equals 5. And now I just want to simplify. So I have negative 6 plus 1 is negative 5x plus 9 equals 5. And then I want to get this equal to, for that, I want to get it equal to 0. So I'm going to subtract the 5 to the other side. So I get x squared minus 5x plus 4 equals 0. Again, this is usually something that can be factored. So if you can't factor this, then double check your work to make sure it's done correctly. But here it's fine. We can factor that. Factors of 4 that add up to negative 5 would be negative 1 and negative 4. And we get x is 1. And we also get 4 as the answer. Now, as I mentioned in the very first problem we did in this section, I would just use the easier equation when you're finding your answers for y. And you don't have to worry about it being wrong, because you're going to get the correct answers if you use that first equation. So I'm going to use this here, y equals negative square root of x. And I have x is equal to 1, and I have x is equal to 4. So I'm going to do this, plug it both in to get the corresponding y values. So y equals negative square root of 1. So y is equal to negative 1 there. Y equals negative square root of 4. So y equals negative 2, which means my answers are 1, negative 1, and 4, negative 2. You don't need to worry about trying to use the second equation. That's more complicated, and you may end up getting a couple wrong answers out of that. So instead, avoid all that just by using the first equation. We see here, I did do a graph for this one as well. And down here, you can see again that it goes through 1, negative 1 and 4, negative 2. Those are the 2 points that I had. And that's the only 2 places where it crosses. We have a circle and we have a kind of half of a sideways parabola essentially is what we have going on this. Okay. All right, here's the very last one that we'll do. It's the last problem in this section. Okay, so there's one like this in the homework, so I want to make sure we kind of go over it. This does give you a hint. It says, make these substitutions. It says, let u equal 1 over x squared and let v equal 1 over y squared. Now, I might be thinking, well, couldn't I just multiply both sides by the common denominator, x squared y squared? And yes, that's true, but then you're going to get x squared y squared on the right-hand side, and you're not going to know how to solve for that. So instead, it's better to use the hint that it gives us here. Now, one thing about that is if I have 5 over x squared, so 5 over x squared is the same thing as 5 times 1 over x squared, which means that's the same thing as 5u. Now, if I have 2 over y squared, that's the same thing as 2 times 1 over y squared, so that's equal to 2 times v. So the very first equation, what I'm going to do is, since I've already gone through the work to change that, that would be 5u minus 2v equals -3. If I use the same logic on this one, 3 over x squared is 3 times x squared, so that would be 3 times a u. And then plus 1 over y squared is just going to be a v. So I made those substitutions, and now I've turned it into a more complicated one into just a linear one that we've done before in the last section. So since it's linear now, I can solve it by either substitution or elimination. I will use substitution here. The first equation, I'm going to leave that alone. But the bottom equation, I'm going to multiply the whole thing, both sides, by a 2, because that way I'll get a -2v and a 2v, and that together will cancel out the v's altogether. If I tried to eliminate the u's, I'd have to multiply both equations by something. So the first equation, left alone by itself. The bottom one, I have 6u plus 2v. Don't forget to multiply the 2 on the right-hand side over there. And now we're going to add all this together. 11u, the v's are going to cancel out there, and I get 11 over here, which means that I get u equals 1. So now I can put this back into either the first equation or second equation, doesn't matter which. I'm going to use the second equation since the numbers look a little bit smaller there. And I'm going to put in a 1 for the u. So I get 3 plus v equals 7. And I get v is equal to 4. Now, these are not the final answers that you're going to have here. Okay, so because even though I get this, my original equation had x's and y's in it, not u's and v's. So what I have to do is I have to use the substitution to put back into each of these to finally get the answer. Okay, so for instance, the u, that's the same thing as 1 over x squared. And so for that, I'm going to put that one in there. For v equals 4, that's 1 over y squared. I'll put equals 4, and I'm going to solve that. So I'm putting substitutions in for each one here. If I multiply both sides by x squared, I'll get x squared equals 1. So I get x is equal to plus or minus 1. Now, if I multiply both sides by y squared here, I'll get 1 equals 4 y squared. Divide it by 4, I get this. And I have to take the square root of both. Now, what I get is I get plus or minus the square root of 1/2 or plus or minus, I should say 1/4. We'll get 1/2 as the answer, but square rooting both sides, you're going to get plus or minus the square root of 1/4. You square root the top number and the bottom number. You get plus or minus 1/2 equals y. So now I have my x and I have my y. So now I just need to put this together as a list of points. So what I would do on this is I get, when x is 1, I get both 1/2 and -1/2. And when x equals -1, I'll get both 1/2 and -1/2. So this is going to have 4 solutions to it, all these right here. So all those would be the answer for that. So there is one question like that in the homework that you want to look at that's similar to this example that we just did. All right, so now with that, that is the end of the notes for everything. So now we have everything is all going to be, we've covered all new material for this course. And so again, tomorrow we're just going to do the review for test number 1. So any questions out there before we end the meeting? All right, looks like not. So I'm going to go ahead and end this meeting. Enjoy the rest of your day. See you guys tomorrow.